Hi student, after learning about quadratic inequality, we have to know how to handle assessment questions, especially the way the question asks, or in this manner, how the question is asked, how do we handle them and present what is required from us. That is a skill which we need to master eventually. So over here, let's take a look. This first question is, represent the solution sets of this quadratic inequality on a number line, which means that there are multiple requirements over here. So solution sets means that the so-called answer to student. Then number line, which we have to represent the answer on the number line. So there are two things that's required. So let's take a look. So I have 15, 1 plus 2x, x 19 minus 2x. Okay, so this is the quadratic inequality. So what happens? We have to expand the bracket. So 15 plus 30x 19x minus 2x squared. So I've been reminding student that when we are solving quadratic inequality, do have the habit to ensure the coefficient of the x squared to be positive. Why? So that it'll be easier for us to factorize later on. That's one thing. The second thing is that for quadratic inequality, we can only use the factorization method to find out where is the x-intercept. No quadratic formula, no completing the square. So this is something you have to be mindful of, and we need to sketch a shape of the quadratic curve to guide us in determining where is the region required. So what do I mean by all this? So now I'll bring all the terms to the left hand side so that my negative 2x squared become positive 2x squared. So I'll have plus 11x plus 15. Okay, so we are supposed to factorize this like I mentioned just now. Take note, when we factorize, make sure that this expression here is always in the simplest form, or if you can reduce, we reduce by dividing both sides. Okay, this is not expression, so it's okay to divide. So I have my 2x x 3 5 is it 3 times 2 6 6 plus 5 11. Okay, plus okay. Then over here we will find out where is the x-intercept, which means that imagine this curve, okay, this quadratic curve, where it cuts the x-axis. So with this, okay, the x-intercept, we can imagine this as the x-axis. So with this, I have negative 3 and negative 5 over 2. So if this over here, they want the curve value more than or equals to 0. This curve value is actually our y value. Okay, y value. So with this more than or equals to 0, so it will be this region over here. So with this, our answer to this will be x is less than or equals to negative 3, or x is greater or equals to negative 5 over 2. Okay, that is, we are done until here. Then for the next part, or the last part on the number line, this will require your inequality knowledge from elementary mathematics. So I have negative 3, negative 5 over 2. So there's an equal, so line will feel like that. Make sure the circle is filled. That's how we handle such questions. Okay. Let's proceed. Okay. The other question, this is a bit challenging because students have a habit when you see wording like completely above, you will change it to less than 0 and straight jump in discriminant. So be very mindful. So this 2 part 1 is actually, I would say, elementary maths question, not even A maths. So they say that the curve y equals to ax squared plus 5x plus a minus b. Okay, this is a quadratic curve. In the case where a is 2, find the set of values of x for which the curve lies completely above the line y equals to x. So what does this mean? So when a equals to 2, so I have y equals to 2x squared plus 5x. 2 minus 5 I have negative 3. So they say this curve, okay, is completely above. If you let this to be y equals to 9, okay, completely above the curve. So the curve is completely above the line y equals to 9. So it's actually this portion here. The highlighted portion is where the curve is completely above the line y equals to 9. So with this, how do we present our answers to the marker? So first thing, we have to find where does the curve intercept the line y equals to 9, which means over here we have to do 9 equals to 2x squared plus 5x minus 3. And with this, 0 equals to 2x squared plus 5x minus 12. And from here, we factorize. Okay, so this one will be 4, 3. Yeah, 4, 3. 4, 2, 8. 8 minus 3, 5. So we plus, minus. So here, you can see I won't be solving till I get the x value. I'll just stop at here. So which means that, let me confirm, 2x times positive 4, positive 8x minus 3x, positive 5x. Yeah, and negative 12. Okay. So my 2 value here will be negative 4. Then the other intercept value will be 3 over 2. So you can see that the highlighted portion, this is the region whereby the curve is completely above the line y equals to 9. So therefore the answer is x less than negative 4 or x greater than 3 over 2. So this is this region, this is this region. So don't always look at keywords and straight away say this is b squared minus 4ac less than 0. So please be mindful. We have to see the context of the questions. Okay, so now second part, say in the case whereby a is 4, now a should become 4, show that whenever in mathematics, when we are asked to show, we are not allowed to use discriminant. Although most students, when they see tangent to the curve, they will say b squared minus 4ac equals to 0. This is not allowed. When we are asked to show, explain, okay, or prove, for example, all this. So we only can find the discriminant value b squared minus 4ac. Then from the value, deduce that it is equals to what. Then we can proceed. So what do? We do it like simultaneous equation. So y equals to x minus 2. This is my equation 1. Okay. Then I have my y equals to 4x squared plus 5x. 4 minus 5 I have negative 1. So these two equations equals to each other. So x minus 2 equals to 4x squared plus 5x minus 1. 0 equals to 4x squared plus 4x. Okay. So from this, we are supposed to continue. How? Now our quadratic equation equals 0, so we can find the value of discriminant. So b squared minus 4ac, value only. So my b is 4 square, my a is b squared minus 4ac. So b is 16 minus 16, so equals to 0. Good. So since b squared minus 4ac is equals to 0, the line y equals to x minus 2 is tangent to the curve. Okay, so this is important. We are asked to show, explain, or prove. Then our last part, find the other value for a for which the line y equals to 2 is tangent to the curve, the other value. Okay, so you can see over here is actually an extension of our part 2. Okay, so over here, let's take a look. So y equals to, okay, same thing, y equals to x minus 2, then y equals to, now without the a, we are supposed to solve for a value, ax squared plus 5x plus 5x plus a minus 5. So because here we are supposed to find, which means that we are solving, we can use discriminant. So you need to know, or we need to know, whether the question want us to solve or they want us to show. Show is another set of presentation. Solve is another set of presentation. The way to present is different, or are different. So with this, my 1 equals to 2. So I have x minus 2 equals to ax squared plus 5x plus a minus 5. Then this one will be using discriminant, which is b squared minus 4ac equals to 0, because we are finding or solving. So with this, I'll have 0 equals to ax squared plus 5x minus x will be 4x plus a minus 5 plus 2, negative 5 plus 2 is negative 3. So with this, b squared minus 4ac equals to 0. So my b is 4 square, b squared minus 4a, c is a minus 3. Derivative is solved, 16 minus 4a squared plus 4a times 3, I have plus 12a. So with this, I have 4a squared minus 12a minus 16 equals 0. So here, I'll divide by 4 throughout. So I have a squared minus 3a minus 4. So here I have a. One of the a value will be the same as the a given to us, which is the 4 here, because the other value. So here I'll have a equals to negative 1 or a equals to 4. This one don't need to reject, I'll say that. Okay, so this one don't need to reject. So I'll say that therefore a equals to negative 1. Got it? Thank you.